Today we're going over 6.2 polynomials and linear factors. So let's say we have an expression of x plus 1 times x plus 2 times x plus 3. And we want to write it in standard form. So right now, this is in factored form. Because these are all prime linear factors, so it's in factored form. And it's nice when it's in factored form because if we need to find the x-intercepts, it will be easy to find when it's in factored form. So what you would do for that is you would set it equal to 0 and solve for x for each binomial. But we'll get to that later on. So now we want to put it in standard form. So to put it in standard form, we're going to multiply two of the binomials. We'll just bring this x plus 1 down and rewrite it. And now I'm going to FOIL this. Multiplying two binomials or FOILing it. So we'll go first, x times x squared, outer, inner, and last. And now I'm going to combine my like terms before I multiply the x plus 1 in. So I have an x squared plus 3x plus 2x is a 5x plus 6. And now I'm going to distribute in my x to every term, multiply it to every term. I'll get an x cubed plus 5x squared plus 6x. And now I'll multiply my 1 to every term. So that's an x squared plus 5x plus 6. And now we just have to combine our like terms and then it'll be in standard form. 5x squared and x squared are like terms, 6x and 5x are like terms. So we have an x cubed, 5x squared plus x squared is a 6x squared, 6x plus 5x is an 11x plus 6. And this is in standard form. So when it's in standard form, you write it as highest degree to lowest degree. And this will give us a couple of different things of information. The constant term is going to be your y-intercept always. So if we're actually graphing it, we'll know that it'll cross your y-axis at 0, 6. And then by knowing your first term here, you'll be able to say what the end behavior is, which we went over in the previous video in 6.1. So just to quickly go over that, the end behavior here, we look at the leading coefficient and the degree. So for this one here, the leading coefficient is a 1. So we say, is it positive or negative? And then in this case, it is positive. So whenever the leading coefficient is positive, the right side goes up. And the degree, we say, is it even or odd? In this case, it's odd. And for odd degrees, it's always the opposite end behavior. So the left side goes down. So we'd easily be able to graph this as well if we needed to. The next thing we're going to go over is factoring one more. So we can factor another one. And sometimes you just need to take out a variable or a number. So we're going to factor 2x to the third plus 10x squared plus 12x. So we're going to take out, 2 goes into all of the terms, and we could take out an x from all of the terms. And therefore we're left with an x squared plus 5x plus 6. And really what we did here was we divided each one by 2x, what we took out, or the greatest common factor. We can keep going here because this trinomial can be factored. You say what multiplies to 6 and adds up to 5. 3 and 2 does. So we write it as x plus 2 and x plus 3, and this is factored form. So this was our standard form, and this was our factored form. Okay, the next thing we're going to go over is actually graphing it. So let's say we want to graph y is equal to x minus 2, x plus 1, x plus 3. So the first thing that we can do is find the x-intercepts. And to find the x-intercepts, we plug y equals 0 in. So we're going to take this whole thing and we're going to set it equal to 0, and we're going to solve for all of our x values. So since this is in factored form, it will be easy to find the x-intercepts. So we're going to set each binomial equal to 0 and solve for x. So we have 3 x-intercepts. So the points are 2, 0, negative 1, 0, and negative 3, 0. So we can start graphing this already. At 2, 0 is an x-intercept, negative 1, 0, and negative 3, 0. Okay, the next thing that we can find is the end behavior. So to find the end behavior, we need to know the first term when it's in standard form. So to find the first term, you're going to take all of your variables and multiply them. So we have x times x times x. That's going to give us an x cubed. And that is our first term. So just by knowing the first term, we can find what the end behavior is by saying the leading coefficient and the degree. And that will determine what our end behavior is. So the leading coefficient, we say, is it positive or negative? And in this case, it is positive. And then for the degree, we say, is it even or odd? And in this case, a 3 is odd. So when the leading coefficient is positive, the right side always goes up. And when the degree is odd, it's always the opposite end behavior, so the left side goes down. So now the last thing to find is the y-intercept. And for the y-intercept, you can either plug in 0 for all of your x's and find your y, or you can multiply all of your constant terms. And a constant is just a number because it doesn't change. It's always constantly that number. So we'll multiply all of these out, negative 2, 1, and 3. And therefore we get a y-intercept of negative 6. So we have negative 6. And that's about right here. And then we're going to use our end behavior here. For right now, we're not going to worry about the turning points. We'll learn that later on. But for right now, we know it's facing down, has to go through these x-intercepts, through this y-intercept, and then back up through this x-intercept. So the last thing here is looking at your relative maximum and minimum. So right here, we don't have a maximum because it continues to go up, and we don't have a minimum because it continues to go down. But we do have a relative maximum, and that's this point right here. And we do have a relative minimum, and that's right here. Okay, we're also going to go over, if we're given the x-intercepts, how to write it into factored form and standard form. So let's say, for example, we're given that we have x-intercepts or zeros at negative 2, 3, and 3 again. So just by giving giving us that. We know this is going to be a cubic because it's 3 numbers. So to write it, we're always going to have it as x minus the 0. So x minus the negative 2 is x plus 2. And then we have an x minus 3 and an x minus 3 again. So we can multiply this out. This will give us x squared. Our outer and inner will be a minus 6x. And our last will be plus 9. We can multiply in the x and get an x cubed minus 6x squared plus 9x. Multiplying in our 2, we have a plus 2x squared minus 12x plus 18. Combining our like terms here, we get an x cubed minus negative 6 plus 2 is a minus 4x squared. 9 minus 12 is a minus 3x plus 18. So this is standard form when we're given these x-intercepts. This is factored form. This is standard form. And if we wanted to sketch this, we could. So by knowing we have x cubed as our first term, we know that the leading coefficient is positive and the degree is odd. So the leading coefficient is positive, meaning the right side goes up. When it's an odd degree, the end behavior is opposite, so it's down, up. We also know that the y-intercept is the constant term in standard form. So this will be your y-intercept, 0, 18. And then we are given the x-intercepts already. So we have a negative 2 and a 3. So since we have 2 3's right here, we can also write this as a y equals x plus 2 and x minus 3 squared. So if we have an x minus 3 squared, that means that by this 0, we're going to have a parabola shape, because whenever we see an x squared, we should think of a parabola shape. So we'll just say that this is about 18 here. So we're going to go down, it's going to go through our y-intercept, and then it's just going to come down, touch the 3, and then come back up. And we knew it was going to be like that because the 3 came up twice. When it comes up twice, it's a parabola shape. So to write these x-intercepts, we're going to use a multiplicity, and we'll just write it as x equals negative 2 and x equals 3 with multiplicity of 2. So the multiplicity just tells us how many times this x-intercept comes up. So it came up twice, so we say with a multiplicity of 2. And that's it.